material, or from one material to another when they are held in direct contact. Conduction occurs in solid materials. In the example shown here, the flame heats the left end of the metal bar. The heat is transferred through the molecule in the metal bar to its right end, where it causes the ice cube to melt. Convection is the transfer of heat by an agent such as air or water. In the example shown, the heater causes the air it contacts to become warm. The warm air rises, creating a current of airflow. As the warm air contacts other objects in the room, it transfers some of its heat to objects. Thus, the air is used to transfer the heat from the heater to other objects. Radiation is the transfer of heat through wave energy and motion. The most common example of radiation is the heat we receive from the sun. For example, if the sun shines through a window and strikes part of the table, the waves from the sun do not heat the air between the window and the table. Instead, the waves from the sun create heat when they strike the surface of the table. The portion of the table in the sunlight becomes warm, while the portion of the table out of the sunlight remains cool.
So, we're going to talk about that many times over the next year. Alright, so here's another one.
It may seem like attic vents defeat the purpose of insulation, but they are a vital part of keeping fresh air circulating throughout your home. An unventilated or underventilated attic can trap heat in the summer months, raising the home's indoor temperature by several degrees and putting a strain on the air conditioning system. During the cold winter months, poor ventilation can cause warmer air trapped in the attic to condense under the roof decking, possibly causing minor water damage. Attic vents can be located in the soffit and roof of a home. Soffit ventilation is provided by installing perforated or vented soffit panels when trimming the outside of the home. Vented panels are installed every few feet along the soffit to allow airflow in and out of the attic. Roof vents can be installed in the roof deck or along the roof ridge. Flexible insulation, often called fiberglass insulation, comes in short bats and long blankets or rolls. The insulation material is often made from mineral fibers, such as fiberglass and rock wool, applied to thick paper. Some come with a radiant barrier backing or a fire-resistant face. Recycled plastic, recycled cotton, straw, paper, and other insulation materials are sometimes available. Bat and blanket insulation is used to insulate below floors, above ceilings, and within walls. Generally, bat insulation is the least expensive wall insulation material, but it requires careful installation for effective performance. Flexible insulation comes in 16-inch widths, suited to standard spacing of wall studs and attic or floor joists. Bats and blankets typically have an R value of approximately R5 per inch of thickness. When installing flexible insulation, fit the material between the studs or joists, starting at the top. Spread the paper edges out so they lap inside or over the studs or joists. Some contractors fasten the paper edge of the insulation to the inner sides of the studs. Others lap the paper over the outside edge of the studs for improved R value. Either method is acceptable. Staple the edges of the paper to the studs, starting at the top and working your way down. Spread the insulation blanket out smooth as you staple down the edges. If the roll is too short, butt another piece up against the first and staple it in place. To cut fiberglass insulation to size, cut the paper facing with your razor knife. being careful not to cut yourself. Then tear the pieces apart.
Yep, you're out of here, I know. See you later.
The coach just called me.
Where am I supposed to be?
See,
Have a good trip.
Loose fill insulation, usually made of fiberglass, rock wool, or cellulose, comes in shreds, granules, or nodules. The loose fill material conforms readily to building cavities and attics. Therefore, loose fill insulation is well suited for places where it is difficult to install other types of insulation. Loose fill insulation typically has a value of approximately R3 to R4 per inch. Cellulose fiber has approximately 30% more insulating value than loose fill rock wool. Loose fill insulation is normally blown into the home using large commercial equipment. Bags of loose fill insulation are dumped into a hopper. A blower then forces the insulation through a flexible hose and into the home. Then, insulation is blown out the end of the hose and between or over the ceiling joists. The installer must wear a respirator to avoid ingesting the insulation material. Note how the installer is placing his hand next to the hose to help distribute the loose fill insulation evenly over the ceiling joists.
Last video.
Rigid foam insulation, also called foam board, is typically more expensive than fiber insulation. Insulation board is very effective in buildings with space limitations and where high R values are needed. Foam insulation R values range from R4 to R6.5 per inch of thickness, which is up to 2 times greater than most other insulating materials of the same thickness. A common application of insulation board is around foundation walls. Below-grade insulation board is applied to the outside of block and poured concrete foundation walls to insulate the basement of a building. It is often applied to the foundation wall right after the application of tar or synthetic rubber-based waterproofing material. The foam insulation board will stick and bond to the wall if applied while the waterproofing material is still sticky. When the waterproofing material dries, it will hold the insulation board to the block or concrete wall. A handsaw is often used to cut thick insulating board to size. The foam board is marked for the cut and then can be easily sawed to size with a handsaw as shown.
That's that. Alright, now let's go over here. Alright, so. Insulation. What, hey, okay, so, really quick, what's the purpose of insulation? Purpose is not to keep the heat out, but to, be more efficient with your home and save money on your electric bill, okay? And make your home more comfortable, alright? How does it work? Anybody know how insulation works?
It doesn't transmit energy or heat or electricity or sound.
Doesn't transfer heat. Well, it stops heat from transferring.
But how does it work? I understand, that's what it does, but how does it work?
What do you see? It absorbs, doesn't it absorb?
Doesn't absorb it. Some, if it's foil backed, it could reflect it, but that's not really what I'm looking for. How does like batt insulation and blowed in insulation, how does it work?
Does it stop airflow?
That is close.
Close
It
to
doesn't really stop airflow. It traps air inside of it and makes it difficult for the air to move. Does that make sense? So the air does move inside of it. It does transfer heat. It does all of the things. It just does it better than other materials. Okay? It encapsulates air. Now, I have a question. If I put a wall of insulation between me and Carrington, right down the middle of the room, just insulation, what, would the temperature be different on his side of the room than on my side of the room? Just insulation.
No.
Why? No, let's say we made two different rooms.
So now we got a wall running.
We got insulation, no drywall, just insulation. Got studs and insulation.
As long as you still have air ducts in both rooms.
Well, let's say we've got this room set to 70 and that room set to 75.
Oh, yeah.
Batt insulation only works if it's entirely encapsulated. Okay? You have to have drywall on one side and drywall on the other, or plywood on one side and drywall on the other. If it's not trapped, encapsulated, the air moves freely through it. So a wind will blow right through insulation. It does not stop a wind. But whenever you totally encapsulate it, it inhibits air from moving inside the wall. But it'll move right through it. So if you don't totally encapsulate, a good example is a bonus room. They insulate the wall, they don't put anything on the back side of it, and they put drywall on the inside of it. So air goes in and out of the insulation constantly, and bonus rooms are always cold or hot, depending on where it's at, right? You guys know, like room over garage or an attic room, that's what we call bonus room. So they have little short walls on them. They have little short walls on the side, and everybody thinks it's because it's the attic that it's so hot, and that's part of it. But the main reason is this. And I have the same thing in my house, and I have it, it's difficult to correct, okay? So you have an attic truss that looks like this, it's got a floor joist across here, and the truss goes down, and it goes down over here, okay? And this is drywall, and this is drywall, and this is drywall with insulation inside of it. nothing on the backside. It's just insulation in the attic. That air is moving in and out of that constantly, and it's not stopping. So, in reality, it's almost worthless. The difference between it being there and not being there is very negligible. So, what you should do is totally encapsulate it by going in here and either putting plastic or drywall or plywood on the backside so that it has drywall on both sides. If it has drywall on one side, it is not very effective. So, what does that mean for insulation in general? It's only as good as the person who installs it and or, because here's the other thing, let's say we have insulation in a wall, so these are my studs, and let's say I got my insulation, got a couple of little gaps in it. It's got a little dent there where there's a hole, and there's a hole here, I cut around the outlet a little too big, and I got a little space around the outlet. Poorly installed insulation, like this, 40 to 60% inefficient. Just by leaving this gap and that gap and a gap around the outlet, you lose 40 to 60% of the efficiency of the whole thing. Not just right here, of the whole thing. So the installation of the insulation is, that's hard, say that 12 times, is difficult. It's difficult to predict if you don't have good insulation on how well it's going to happen. A gap, you can't really see it, but if it doesn't go all the way to the top and it doesn't go all the way to the bottom, and it's and you got gaps everywhere, and the net, a good person is going to go, make sure it's totally filled. There's no holes. The outlet is not only cut around, but stuff stuck behind it, and it's all the way to the bottom. This insulation is 40 to 60% better than that, and that's just a little bit of time. Okay? So, when you're looking at all this stuff, understand the application. Alright? So, what R value do we look at for walls? Typically R13, right? And it may say here, it may conflict with what I'm saying, but in our area, R24 is about peak. Anything above R24 they say is waste. There's too much insulation, you'll never pay for itself, or it's not cost effective because we don't have temperatures that we require higher than R24. And we're not talking about the insulation, we're talking about the entire system. The drywall, the insulation, the plywood, the brick, whatever you have on the outside, the entire system is R24 is what would be a really good goal. So that's like 2x6 walls with R19 in them and a 1-inch rigid foam insulation around the outside gets you to R24. Okay? That's like ideal, perfect situation, best of the best. What about attics? R24? It's ideal for the walls. Why wouldn't it be ideal for the attic? Okay, so where does heat go? Up, right? Heat doesn't go sideways, it very well. So we worry more about losing heat through the attic than through the walls. And we also trap exterior air in the attic through venting and everything else. So it's not really encapsulated, is it? For the most part. So in an attic situation, we want to have R38, R40. I want to say R38 is what they recommend. I have to double check. over like R50 is complete waste. Actually, it does the exact opposite of help. It hurts. Now you can't get rid of extra air that you need to get rid of. Okay? So, when we're looking at all this stuff, there's always too much, there's always not enough, and then there's that peak in the middle where cost, effectiveness, and comfort meet. I always like to tell a story of, my uncle, Dana, he, built a house in Dongola. No, Alto Pass. Built a house in Alto Pass. And, he put plastic everywhere. I mean, he heard that, we need vapor barrier, he didn't want any air filtration into his house, he plasticked everything. Taped every joint, everything's plastic. In about a year and a half, not even a year and a half, under a year, he started getting mold everywhere. And then the ceilings started falling off because he trapped all of the moisture in the house. So the moisture that you breathe, the moisture out of the bathtub, the moisture out of the toilet, the moisture out of the sink, dryer moisture, all of the moisture in the house gets trapped. It can't get out. Where does it go? It goes to the plastic, and then it sits on the plastic, and the plastic and the drywall absorbs it, and then the drywall starts falling off the wall. So there's great vapor barriers are great. They're needed. You have to have them, but you can't put them on the ceiling. You have to have some way for the air, for that moisture to get out. Put it on the wall. Makes sense? So, thermal and air infiltration, exfiltration, and insulation all go together. Heat transfer. When we're building, and we're going to get into this a lot more in the green, but when we're building, you see this here? See this pipe? See that hole around the pipe? Those are the leading causes of infiltration. When we drill through the floor, or we drill through into the attic, we have to put a pipe through into the attic, and we don't seal that pipe. That's the leading cause of air infiltration. Drill a hole for a wire, if one wire goes through, you got a 2-inch hole, and now you have air leaving your house through that 2-inch hole constantly. And it is constant. It never stops. When it's cold, when it's hot, it never stops. So you have to foam those openings and seal up all of those areas for your house to be what you would consider to be efficient. We don't have to, there's always too much, but on the same hand, we are so far from too much most of the time that we could do a lot more. My house needs this. Guys, I'm not saying that I've done all this. I haven't. I'm lazy. It costs money. It takes time. It's not very enjoyable crawling through the attic, pulling back insulation, foaming little bitty holes. But if I was smart and it wasn't 100 degrees all summer when I'm off, I would do it. I'm not going to go into how heat transfers. We'll get into that more in green construction. Okay, here we go. Here is Maldives based on comfort standards, insulation costs, local climate conditions. North America is divided into zones according to the climate. So 1 is the Florida, is the Keys. 2 is Southern Texas. 3 is here, all the way over there. 4 is where we're at. We're in number 4, yellow. 5 is Chicago. 6 is the Dakotas and Minnesota and Michigan. And 7 is Canada, and you got a little bit of 7 on the top of the Rocky Mountains. It doesn't say what the insulation rates are. It would be nice if it did, but it doesn't. Here's some different types. You have flexible, rigid insulation, batt insulation, blanket insulation, loose fill, reflective is what Josie was talking about. Here's flexible, non-faced. Faced means it has paper on one side. Unfaced means it doesn't. Here's a loose fill insulation, my least favorite insulation of all of them. The reason why I don't like it is if you truly blow it in loose and you have good attic ventilation, and of course most houses do, the wind gets in your attic via the vents and it moves it all around. So right now in my attic, if I walk in there, I did this because I'm cheap and I would not do it again. I didn't do it on my addition. But if you walk into my attic right now, there's spots that have 2 inches of insulation, there's spots that have 15 inches of insulation because it's blowed all around and moved. So I'm not a proponent of this. Don't get me wrong, done correctly with, they have chemical additives and they can blow it in wet and then put a little bit of glue in there, and that is very, very good. But loose fill that has no water or glue in it, I'm not a fan of at all. I do not agree with it. Every time I go to switch a light or to cut a hole in the ceiling, I get a massive amount of this junk in my ceiling too. Or in my room, and I don't like that either.
Or your mouth.
Your eyeballs and tasting it. Mice like it. They crawl into it, bury through it. I just don't like it. Foam. All right. Foam is a great product. Used in the right location. It can be overkill. It can, since it is a vapor barrier and an insulation in one. Remember what I just told you about spraying the ceiling or putting plastic on the ceiling and putting plastic on the walls. If you use this incorrectly, you can seal your house up so much that you have the same problem with having a vapor barrier and everything. You have too much moisture in your house. So then what do we do in those cases? We put dehumidifiers in our air conditioner systems, and we put outside air handling units that bring in X amount of outside air, and then we exhaust them a little bit of inside air out, and so we can exchange the air in the house. But foam is a very good product because it does seal up. It is a vapor barrier. It doesn't move. It's permanent. Downsides of it. Anybody know the downside of it? It's expensive. So I could probably build a 2x8 wall and put fiberglass in it for the cost difference between doing a 2x4 wall with batt insulation. It's that much more expensive. It can be $3 a square foot, $4 a square foot per inch. So if you really think about it, you normally have more ceiling and walls than you do floor space. So if you have a 2,000 square foot house, you might have 4,000 square feet of insulation, walls and ceiling and floor. Maybe 6,000 if you both foam in the floor. At $12 or $13 a square foot, 3 or 4 inches thick, that could put you in the $40 a square foot for insulation versus batt insulation of being $2 or $3 a square foot. Change the cost of your house from $100 a square foot to $140, like that. So the cost is really expensive. So how do we combat the cost? Why would anybody do it if it's that expensive?
Because you save money in the long run.
Yes. But there's a better way of doing it. Might take years for you to save that money. It's called flash and batt. So you go in and you spray 1 inch of foam, so you get 7R out of that 1 inch, because foam insulation is R7 per inch. So we get R7 out of 1 inch, where R13 is 4 inches, right? So R7 out of 1 inch, and we get our vapor barrier, and we get our air seal with 1 inch of that foam, and then we put batt insulation on the inside, and we get R13 plus 7, so we got R20 insulation for, you know, $3 a square foot instead of $12 a square foot. Does that make sense? Because 4 inches of it would be $12 a square foot. So we get most of the benefit of the vapor barrier and the air sealing, and we get an additional insulation. But then we put fiberglass on the inside. Fiberglass costs like 50 cents a square foot, if that, 35 cents a square foot. Instead of spending $12 a square foot, we spend $3.50. That make sense? So, it's called flash and batt. So you spray foam 1 inch thick, and then you put batt insulation on the inside. It's by far, right now, the most effective bang for your buck you can get. Does that make sense to everybody? How you're using the benefits of one and the other, and the cost effectiveness of both. That will pay you back a lot faster than spraying the whole wall. It might take 20 years to get your money back out of it. You'll get your money back. Reflective insulation, just got a foil back and it kicks the radiant, you know, the 3 types I talked about: conductive, radiation, and convection. Radiation is heat rays going through stuff, so reflective insulation reflects the heat waves. What time is it? Okay. Where to insulate? You want to insulate anywhere between what you want to be heated and what you want to not be heated. So sometimes you'll not insulate the garage and not heat the garage, but if you insulate the garage and heat the garage, then you would insulate the garage, right? Whatever you desire to be heated needs to be encapsulated in insulation. Bottom, sides, and top is the best. A lot of times we forget about insulating the bottom. I know I did. I was in a hurry. I had 30 grand cash in my pocket, and I wanted a house. So, am I gonna spend $3,000 insulating the floor system? No. I don't have an extra $3,000. In retrospect, I wish I would have done it. But if you insulate underneath, you insulate yourself from the ground temperature, which is always 50 degrees. We insulate the walls and the roof or the attic, depending on how you're going about it. And that way you're totally encapsulated. It's really good. So this is how you can insulate your floor system, or you can run insulation underneath your slab. So you can break it with, this is called a thermal break, or you can insulate underneath and down, and then insulate on the outside. I don't like this way. Don't get me wrong, it works. Why wouldn't I like it? You guys see this? This is insulation that runs up and runs out in between this floor slab and here. Why wouldn't I say that's a good way? You have water issues, you have bug issues, you have mice issues. If they get underneath into your crawl space, they can come up, they'll eat through this insulation and come up. That's why I don't like it. I would rather do insulation up against the wall and under the floor, and on the outside of the foundation. People don't like that because you can see it, so you have to do something over the top of it. But that is the best way, in my opinion. Now we're insulating from the outside and the ground at the same time. Existing foundations, they're showing to come in here and put it on the outside all the way around, just like I just said.
So when you put that vapor barrier down on your, for your concrete, so that basically you're, insulating.
No, the vapor barrier is doing what it's doing. It's eliminating vapor. So your floor will sweat. Concrete will absorb water. It acclimates to what it's around. So if there's water under the slab, and then you heat the inside, the water will come up through the concrete and sweat on top of the concrete. So you get water. That's why we put the vapor barrier. Now, we put insulation underneath it to stop the temperature from coming through the concrete. Concrete is not a very good insulator. It's like an R.2 or something like that. It's very, very low. It pretty much transfers everything.
I heard you can add like a Dawn, which is like a foaming ingredient to concrete or cement when you're blowing it, and you can use it as insulation. So maybe that'll make the R number better.
I don't know about that. I've never heard of that before. I've heard we can use Dawn dishwashing liquid and add it to concrete, and it acts as a water reducer,
Oh,
so it
yeah.
looks like it has more water in it, but it doesn't. But I've never heard of spraying it. Now there are sprayed cement. It's like cement mixed in with paper and other ingredients, and they can spray it into your wall, and it works as a very good insulator. The problem is it's impossible to remove. I mean, it's like literally sledgehammers and jackhammers to get it out. It turns into concrete. It's cement, but it's really, really hard, and it works. And I would assume, guys, here's another advantage to foam and to what I just said, cement insulation. It is considered structural. So if you figure it into your engineering when you're building your building, you can put less studs, you can put studs further apart, you can load more weight onto a wall that's insulated with foam, because it is closed cell. Open cell is not considered to be structural, but closed cell is considered to be structural. So it actually makes your building stronger by having it in there. Does that make sense? Where fiberglass doesn't. So if you need extra strength of a wall, you would have to have an engineer design it, but you can literally go in and build a regular wall and spray foam it, and it's like, I can't remember what they said, like 6 times more, 6 times stronger or 6 times more efficient at transferring a load than it would be without it. It's pretty amazing.
The old way they used to do walls, with like the slats and put the plaster, is that just all they would do with that? Just put plaster on it?
Just put slats and then they just
I've had to tear
rub
so
it
many of
off,
those
rub
walls
it,
out
they put a mat, sometimes they'll put a wire mesh,
Wire.
sometimes they don't. They just rub it on the wall
I've had to take
and make it
stuff
flat
out
as they can get it.
with the wire stuff, and
It sucks.
it's
It's
awful.
terrible.
So
I would
heavy.
rather knock down a house than to mess with it.
yeah, that's fair.
So we're gonna do this. I've got 2 of these. These are blower door tests. We do this in green construction next year. We could also do it in weatherization, but it is how we test the house to see how well it's the air infiltration. It's mainly for air infiltration. not insulation, but air infiltration. So we put this in, now it's starting to be code in certain, like Carbondale, I think it's code that you have to run a blower door test and it has to meet a certain standard. But this is a blower door and you put a fan and a meter and you set you turn the fan on, you adjust the fan setting until you have a negative 0.5 barometer on the inside of the house. And then you open it up, and once you open it up, it will tell you the difference of how much air is flowing through the fan. So there's a couple calculations there, but it registers outside pressure versus inside pressure and tells you how much your house is leaking.
So they do that at the end, I assume?
Yep.
So what would they do if it's not?
Well, I mean, you have a few, so we're gonna go inside the house, and we're gonna find out where it's leaking. So let's say we have a vent, and that vent has a big gap around it. So we would take the vent cover off and be like, oh, right here, so we're gonna foam or caulk or whatever we wanna do to seal that. Oh, it's coming around your attic door. What do we gotta do here? Oh, this window is leaking. Why is this? We'll take the trim off of it, insulate around it, figure out, I mean, is it a poor efficient window or is it, is it installed incorrectly? What's the problem? Another thing that might be an issue is seals around doors, holes around the furnace going into the attic, or into the crawl space, floor vents that have big gaps around them. So you just go around and you find what the problems are and you seal them. Now, of course, you want it to be at about 0.5 difference. You want to bring in a little bit of air. If you get too good, then you have to physically bring it in by putting a fan or coming up with some type of air evac unit. And it's more efficient and better to do that, but it's not cost effective. I mean, it's like, okay, let's go caulk up every one of these windows and now let's spend $5,000 on an air evac unit. It's not even called an evac, it's called air, air infiltration system. So, would you rather just bring in a little bit of cold air around your windows or spend $7,000 to bring in tempered air into the building? Because that's really what it is. It's another HVAC system that's hooked to a little vent that goes outside, and then it comes into this little bitty HVAC unit like what you would have in a hotel. And then it pumps that air to all the rooms that you need the air in, the living room, the kitchen, the bedroom, there'll be a little vent in the corner, and it's pumping in tempered air into each one of those rooms, so it's like running another air conditioner. Because you sealed your house too tight. Advantages, yes. You can filter the air that's coming in. The air that's coming around the windows has whatever contaminant that's outside in it.
Probably gets expensive to run the way you're doing it.
Yeah, it's a pretty small unit. It probably doesn't offset the cost of buying the unit, but it probably does offset the cost of using it. But it's little. They're not very big. It's just tempering the air to the temperature of the house. So you're pumping in the same temperature air. But it's filtered air, so there's no pollen, there's no dust if you're on a gravel road, doing all that kind of stuff. There's some advantages to it. Indoor air quality is higher, but there's a front-end loaded expense that goes with it. And I've literally there's a guy that sealed his house up really, really good there, blower tested everything, got it 100% sealed up. He started having problems. He goes in his laundry room and cuts a hole in the wall and puts a 12-inch vent. So his laundry room has got a vent on it that is all year long bringing in cold air or hot air, depending on what it is. But he had to have it, or otherwise the air didn't exchange in his house. So there's too much and not enough. Yeah, there's a lot. We're starting sound installation on Monday. Tomorrow we have, I think, I haven't walked out there, but we have the sheeting